after we've gone and experimentally determined what a rate law is, that will help us try to figure out what the actual reaction mechanism is. But just because you've come up with a mechanism doesn't mean that it's the right one. There are different mechanisms can give the same rate law. So first of all, I'd like you to just look at this top part. Here is a one-step mechanism for how ozone might break down into normal diatomic oxygen. If two ozone molecules collided, bam, and they just broke into 3 normal diatomic oxygens, this would work as a one-step mechanism. So that must be an elementary step. So for that first mechanism, the rate should simply be K and then the concentration of ozone squared, because that was the only elementary step in the process. So this is our first possibility. And that would fit with the rate law that had been experimentally determined. Now, here's a different one here on the bottom. This is a two-step mechanism. In the first step, a single ozone breaks apart into regular diatomic oxygen and monatomic oxygen, which is very unhappy by itself. Why break apart? The ultraviolet light gave it so much energy that it separated. And then after that, this lonely oxygen here manages to collide with another ozone. And as a result, then the two break apart into 2 diatomics. That is from a collision. And so here we have an elementary unimolecular reaction and an elementary bimolecular reaction. Do those actually add up to the same thing that we were expecting? Well, if we look at these and we just add these together, we can see that the one that just has the single atom cancels out because it's on the right and on the left. So on this side, we would have 2 ozones, and on this side, we would end up with 3 diatomic oxygens. So all in all, it gives us the same starting point and ending point. What is this going to look like for a rate? Well, we have to do the 2 things separately. The rate for the first elementary step, well, that was unimolecular. I'm going to call it K1 since this is for the first rate. And the concentration of ozone appears simply once. That looks like this. Here's the rate at which it's going this direction and breaking up into these 2 items. And then I'll look at the second step. It is bimolecular, K2. And it's a collision between ozone and monatomic oxygen, O3 plus O, becoming O2 and another O2. And this is happening at a rate K2. But what is the overall rate? After this happens, then that happens, right? That wasn't in existence before. When I'm trying to do these rates, the only thing that should appear is products or more likely reactants. That isn't in the overall equation. Ozone and regular diatomic oxygen. So I can't have this guy appearing in my rate. But remember what we said about rates before. We could relate this rate to that rate to that rate, because when this was going down, this is going up. This is also going up. And because they all have a coefficient of 1, it's all the same number. The reaction rate, 1, is going to be the same no matter whether we're talking about O3, though that would be decreasing, or either of these where it will be increasing. I can just use this in place of O. The overall rate, I'm going to keep the K2. I'm going to keep the ozone. And then in place of this O, I am going to write K1 and ozone again, which then I can say looks like K1, K2, and ozone squared. So we end up with the form being the same. We still have to go out and calculate what is K. K1 times K2 should end up equaling K, but this concentration part is exactly the same. And so We cannot tell the difference between these. Even though these have different mechanisms, they end up with the same rate law. We would have to do a different experiment to figure this out. In the case of the ozone, if we just put the ozone in the dark and tried to do this, we would not end up with much rate at all. But as soon as we expose the ozone to ultraviolet light, everything would start going, and we would say, oh, it's not colliding that's starting this. We could eliminate this as a possible mechanism because it's just not happening at any significant rate. But as soon as I illuminate it with ultraviolet light, boom, things are happening like I expect them to. And these are always in the realm of being theories. One experiment that contradicts it will knock a mechanism out of the running as being the true mechanism. So you might come up with one and it might stand for 50 years until somebody says, whoop, I did this experiment, and guess what? It proves what you had come up with is wrong. This is real science in the terms of coming up with a theory, doing experiments. I can never completely prove it, but it can always be disproven.